All right, let's do another example before we move on. So this example here is going to be the integral from 0 to infinity for, say, e to the negative x over 2 dx. Now remember, this issue here is going to be this infinity. So what I'm going to do is I'm going to chop it off, and I'm going to say, let's just look at a finite integral. So I'm going to take the limit as b goes to infinity for the integral from 0 to b, e to the negative x over 2 dx. Now remember, the reason why we do this is because this is a simple definite integral that you've always been doing. So it's nothing new. We just simply split that up. So we split the infinity to b, and then we take that limit. Okay. Now at this point, you should be pretty good at taking the antiderivative of things. So let's see if we can do that. So we got the limit as b goes to infinity. Now the antiderivative for this is going to be e to the negative x over 2. Now let's think about this for a second. If I were to take the derivative of this and work backwards, I would have negative 1/2. So I'm going to put a negative 2 out front, and that's how we find the antiderivative of that. If you want to use u substitution to compute the antiderivative, that's fine. Any method will work. I don't really care what you do as long as you can find the antiderivative very easily. And we're going to go from 0 to b. Okay. And we're going to have some minus signs in here, so we've got to be a little careful. So we have the limit as b goes to infinity, all right, of negative 2 times e to the negative b over 2. Okay, that's the first guy. And then I'm going to subtract, and this is going to be negative 2 e to the 0. Okay, now let's clean this up a little bit. We know that this piece here is going to be 1, just the e. So that's going to be equal to the limit as b goes to infinity for negative 2 e to the negative b over 2. And this is going to be plus because we have a minus minus, so that's going to be plus 2. All right. Now the question is, what does this thing do? Okay, so we're going to have to remember how these things work, how these things look geometrically. Now these are very geometric answers, so I'm going to plot these down a little bit. Okay, so let's recall this in a second. E to the x looks like this. So this is e to the x. Y is equal to e to the positive x. And you can see that we have exponential growth. But we actually have a minus sign. We don't actually have a positive x. We have a minus x. And it's going to look like this. It's going to flip it across the y-axis. So this is what y is equal to e to the negative x. Okay? Now, what you see here is that this tends to 0. In this case. All right. So what we see is that this whole piece here is going to 0. So this limit is going to equal to 0 plus 2, which is just equal to 2. All right. So thus what we say is that the integral is convergent. So thus the integral is convergent. All right. Now, here's what we're going to do next. Okay, so note, we fully understand what happens when we integrate from a to infinity of f of x dx. What we say is, okay, we don't really want to do this. We want to look at a finite sum, or a finite integral. So we're going to take this infinity, and we're going to write this as the limit as b goes to infinity for the integral from a to b of f of x dx. Now remember, you're going to have to write all this down to get full credit on the exam, the actual limit part. Okay, so we just took the infinity and split it up. So what happens if I go to negative infinity, for example? Let's consider that case, that possibility. So now let's consider this guy. What happens if I said, let's go from, say, negative infinity to b of f of x dx. Now, in this case, the negative infinity is the issue. We don't have any positive infinity. So what we're going to do, it's the same idea. What you're going to do is you're going to say, let's take the limit as, and I'll call this one a, the bottom one a, and the top one b. I'll say let's take a to negative infinity, and I'm going to integrate, I'm calling this a, to b of f of x dx. So in other words, if you ever have a negative infinity, you do the same game. You say, okay, well, let's call this a finite thing like a, or a different letter, b, c, doesn't matter, and then take the limit as b goes to negative infinity. And you can use any of the techniques from your Calc 1 class from taking limits. All right.